Alrighty, folks, we are going to go through this problem here, the when we started in class, and again with the tips that I showed you before for making these diagrams is we are going to first of all start with what we've been given, and of course don't panic. Alright, so we're going to find the enthalpy change for that first reaction on top there. Let me just rewrite it right here below. There it is there, the halogenation, if you will, of ethene to make a halogenoalkane. We're going to first of all look for these reactants here in one of my other reactions. Okay, so either C2H4 or HCl, and I see that I have C2H4 right there, and it's produced by carbon and hydrogen. So I can put that down below here and say if I have 2 carbons plus 2 hydrogens, then that will make that. Okay? But you'll notice that in the upward reaction, okay, the products up here also include an HCl. Well, where did the HCl come from? It's not anywhere in my reactants here, so I have to fit it in. So I'm going to go say plus HCl. Okay? And now this HCl remains unreacted and just ends up there as before, like I had in the original equation. All right? So I have the C2H4 and the carbon and hydrogen taken care of. Now I need to look at the HCl. Well, HCl can be produced by, you'll notice right here, by hydrogen and chlorine. Okay, so I'm just going to have a half H2 plus a half Cl2. But I'm missing some stuff, and that is I'm missing some extra carbon and some extra hydrogens because I need to have somehow, well, 2 carbons. Had to move it over there a little bit. Okay, there are 2 carbons. I need to have 2 H2s remaining. So I need 2.5 in total, not just 1/2, but 2.5. So I make this into a 5. Okay. And now on the bottom reaction, notice that everything balances out. I have 2.5 hydrogens here, okay, and then I have 2 there and a half of a hydrogen H2 molecule there, right? A total of 5 hydrogens in total, just like on the right-hand side. Same can be said for the chlorines. I have 1 chlorine atom on the right, 1 chlorine on the left, 2 carbons on the right, 2 carbons on the left. That all works out. And you'll also notice that these here are the same as those there. In other words, that's my third equation. Oh, pardon me, let's get rid of those. And here is my fourth arrow. Okay, so I can just start plugging things in. So this is going to be 52 kilojoules here. And then the one to create HCl is negative 92. And the one to create the C2H5Cl is negative 109. And this is the one that I'm trying to find out, delta H. So the arrows have to all start at the same place and end at the same place. And what you notice is that the arrows all start here and then they all end here. Okay? So you can either go, you can go this way, or if you want, you can go direct that way there. Okay? And it's the same amount of energy change regardless of the path that you take. So then all I'm going to do then is I'm going to say that start at the beginning there, and it's going to be negative 92 plus 52, and then plus delta H has to be the same as negative 109, right? So this path is the same as this path there, okay? So then all we have to do is finish solving that equation you can just add 92 to both sides. So negative 109 plus 92 minus 52, and that is equal to your answer, which is negative 69 kilojoules, like we said at the beginning, right over there. Okay, so that's how you get it. Hopefully that makes sense. We'll have lots of practice on Friday. See you then.